So in this video, we will start on a topic called scene understanding. And evidently, scene understanding is still, the understanding part is still a research topic. But nevertheless, over here, we will start with a much simpler task. The task that has to do with placing boxes around objects, the so-called object detection task. And before we start on this kind of task, I wanted to present a little bit of a block diagram of a system, a video analytics system that I'm going to just start drawing so that we understand all the elements of what we're trying to build. And as we will realize that everything we have done up to now, many of tasks of classification and as well as regression are kind of integrated into that kind of system, as we will see a bit later. So I want to start let's consider a system that consists of cameras, a network of cameras. These cameras are evidently, could be potentially many, let's say, application of video surveillance system for physical security in important spaces, strategic spaces like airports. Typical number of cameras in a US airport is around 2,500 of those cameras integrated into a network. Okay, and this is the cameras are transmitting frames over a protocol, video streams over a protocol called, let's say, real-time streaming protocol. The details of that is kind of irrelevant right now. And a typical frame rate is around 30 frames per second. And the payload that they are transmitting, they're transmitting compressed video. So the payload is also known as a protocol H264, 264 or 265. And this is basically the protocols that are underlying the compression mechanism to minimize the rate. And minimization of this kind of rate is kind of important because, as we'll see later, in any real-time kind of application, you are always fighting against latency, and you don't want your latency to exceed a certain target, as we have seen in an earlier kind of video. And just to give you an order of magnitude over here, what we are dealing with a system like that, the whole system should be able to process, if we have, let's say, 2,500 of those guys over here with 30 frames per second, then we're looking at 75,000 frames per second. That's a kind of a tremendous rate that we can actually need to process with our pipelines, this kind of streams. Of course, this is also an important kind of consideration, a kind of a different perspective. It's almost impossible to do that in a public cloud like AWS, which is, and therefore many cloud providers actually are placing local compute, storage, and networking, the so-called edge clouds, into those locations, such as airports and other strategic kind of locations where large network of cameras needs to be supported for that specific reason. It's impossible to transfer this information over the internet. Okay, so the first thing that this stream is undergoes is this kind of a capture, where we take the stream, we decompress it, and we are actually extracting the frames, and all the subsequent kind of processing is going to be done on a frame-by-frame basis, at least in this simplistic sort of approach that we will have here. So we will be designing what is called this video analytics pipelines. And we call them, of course, pipelines because themselves they consist of multiple stages. We'll see that in a moment. And those pipelines are producing at the output JSON streams. So everything is kind of real time. Frames are coming in, JSON streams are coming out. JSON is a format that stands for JavaScript Syntax Object Notation. It's actually a very popular format to transmit all the information that you have extracted out of those frames. And what kind of information we're talking about here, we will see now, but more importantly, we have these JSON streams are typically are transmitted over another streaming technology that is able to implement some kind of publish subscribe mechanism where they publish this information, and whoever wants to receive that information, they subscribe to it, and then that's how you build sort of scalable systems. And that's beyond the scope of this kind of discussion, what happens later. But what is really in scope is to understand what is really happening over here, what kind of information we are interested in. So let's assume that we have at the input over here, we have let's say the image of a person. Okay, so this frame is actually coming in, and what is going to be produced at the output is a couple of things that are going to be produced. The first is in many applications we are interested to superpose the frame, the metadata information that we are, let's say, define a bounding box around that kind of person. So that is bounding box is typically represented by an so-called top left coordinate x comma y, and we're talking about these coordinates are typically expressed at a frame coordinate system. So a frame coordinate system potentially placed the 0, 0 right here. So that is a frame of potentially h pixels by w pixels. As we discussed earlier, the resolution is not very high. So we're talking about something of the order of the input frame could be, let's say, 640 by 640. And so that the corresponding height and width over here could be the same. And the other dimensions over here that the bounding box is being specified is with so-called HBB. I will call this the height dimension of the bounding box, and of course the corresponding WBB, the corresponding width dimension of that kind of bounding box. So our job at the simplest possible kind of pipeline is to just position those bounding boxes around objects of interest that the classes I would like to be able to do, and that task is going to be called object detection. And we'll see also some other subsequent tasks in a moment as to what we are interested in to do. Okay, so our y hat, if I may call it like that, which is basically what it is going to be included inside this kind of JSON, one frame after another stream, is going to be many things. Could be the class ID, the confidence value, and something that we'll call later, associated with some other threshold that we'll call later tau, and the bounding box information, which itself consists of the coordinates x comma y that I called, plus the height and width dimensions. And this will be just for the specific frame, and we'll have many of them, one after another. Okay, so that's basically the task, and what we need to be very careful is to maintain some form of assumption about latencies. This will be important in what kind of algorithms that we will be selecting to implement over here. So typically for object detection, we're talking about few milliseconds. And of course, there are plenty of optimizations that in reality we are actually making to achieve this target. So the discussion about implementation latency will be outside of the scope, but I just want to mention here the so-called latency. So budget is for object detection just few milliseconds. Okay, so that's something that we will potentially see a bit later as we review some of the code which is implementing this kind of object detection logic. Okay, so now what we will do is we will start explaining a little bit more about object detection and see some kind of a video that is going to demonstrate that for us, and also discuss the other tasks which are more advanced than object detection, that are a bit outside of the scope of this introductory kind of course, but it's actually good to know, as we'll also discuss some of the data sets that we'll be using to implement those tasks. Okay.